HVAC Temp Rise formula converts measured volts and amps and the temperature rise into the actual airflow in cubic feet per minute, so you can verify system performance quickly and accurately. Start by measuring and recording the supply volts and the motor amps at the same operating point. Multiply volts times amps to get real electrical input to the fan motor, then multiply that product by 3.414 to convert electrical watts into thermal recovery BTU per hour equivalent. Next, measure the temperature rise across the coil with a quality digital thermometer. Take 3 readings, return air, supply air, and outdoor if doing full system checks, and average multiple readings after at least 5 minutes of steady operation to avoid transient errors. Use 1.08 as the heat capacity factor for air in BTU per hour per cubic foot per degree Fahrenheit in the denominator. Do not substitute other constants unless you know the specific humidity and pressure corrections. The full formula is CFM equals volts times amps times 3.414 divided by open parenthesis 1.08 times temperature rise close parenthesis. If temperature rise reads low because of restricted airflow, double-check static pressure and filter condition. Clean or replace filters and inspect the coil for debris. Then remeasure. Compensate for long sensor leads or poor probe placement by measuring within 2 inches of the grill or coil return and ensuring probes are perpendicular to airflow. If readings swing more than 2 degrees Fahrenheit between repeats, allow additional stabilization time and retest. For motors driven by variable frequency drives, use true power measurements with a power meter rather than volts times amps to avoid errors from phase shift. If only a clamp meter is available, note that readings will be approximate and verify with a secondary method like anemometer or pressure-based airflow calculation when accuracy is critical. One of the biggest issues is inaccurate temperature rise due to poor probe placement causing false low or high readings. Fix this by placing probes in well-mixed airflow 2 inches downstream of the coil and averaging 3 1-minute steady readings. One of the common problems is using nominal volts times amps on variable frequency drives, which yields wrong CFM and poor HVAC performance checks. Fix that by measuring true watts with a power meter or using manufacturer motor input charts adjusted for frequency and drive efficiency. One of the frequent mistakes is forgetting humidity and pressure effects when extreme conditions exist, which skews the 1.08 constant. Fix this by applying humidity-corrected air density charts or using psychrometric tools for precision testing in high humidity or high altitude situations. BigHomeProjects.com lists trusted local HVAC contractors and resources so homeowners can connect with pros who properly measure temp rise and airflow using correct CFM calculations. The directory helps contractors get work by showcasing verified service capabilities and client reviews, making it easier for homeowners to find technicians who follow these exact measurement and calculation best practices.